Hello, friends. This is Jim with Science Talk. I have a little bit of an interesting thing going on here. And you're looking at basically a diagram, staring straight down at the North Pole, showing the Arctic Ocean and surrounding areas. And what this story is going to be discussing with you is what's going on in the Barents Sea. Basically, it's losing its ice. And the Barents Sea could soon resemble the Atlantic Ocean more than the Arctic Ocean. Okay, so a little bit of a background before we get into the particulars of this report. What do we have going on here? Okay, here's the Arctic Ocean. This whitish area is basically the summer ice average extent. So this depicts the average sea ice extent during summer months. Wintertime, historically, it would extend through the Chukchi Sea, through the Bering Strait, right where the cursor is, the Bering Strait, out into the Bering Sea down here. Here's Anchorage, Valdez. There's Fairbanks. So this is about where I live. And Point Barrow. Here's Prudhoe Bay, big oil industrial sprawl on the coast there. Point Barrow is the most furthest. Let me start it again. Point Barrow is the furthest located point on the North American continent. Obviously, these are further north, these locations, but this is the actual continent itself. Point Barrow there. So we're looking at about 72 degrees of latitude there. Here's the ring right here. It should be about 80 degrees north latitude. And of course, there's 90 right at the pole. Here is the Barents Sea. This is the Barents Sea right here. Okay. You have the Laptev Sea, you have the Kara Sea, you have the Beaufort Sea. We see Inuvik here. This is the region for the Mackenzie River Delta. So the Mackenzie River just empties here right into the Beaufort Sea, and we've actually, using isotopic tracing, have found a segment of that river goes this way and travels down through the Bering Strait. That's interesting. When I was a part of a team doing sea ice research, this was our domain right here. We would come up, we would travel the Barrow, and we work off here in the Chukchi Sea. So you can see Victoria Island, here's Baffin Island, here's Greenland. I did a video looking at this portion just north of north of course, where the sea ice has actually melted away twice this year, never been recorded. So I did that segment along with some simulations. You please check out that video. And so I got the Chukchi Sea. This, of course, is Russia over here, and so on. So, Greenland Sea, Iceland, the Norwegian Sea. Okay, Greenland, Iceland, Norwegian Sea. This is taken collectively, it's called the Jin Sea. Greenland, Icelandic, Norwegian Sea. This is basically where the Gulf Stream terminates. At that point, it's something that's called the North Atlantic Drift. This is where it terminates. This is where it gives off its heat, keeping Scandinavia and the UK warmer than it should be for those latitudes. But it gives off its heat. It's now very cold, salty water. It's very, very dense. It sinks, and we start the return flow called the North Atlantic Deep Water. It's the part of the Atlantic Meridional Overturn Circulation. And it's the start more conventionally called the conveyor belt. So here's more of a straight-on shot. This is the Barents Sea right here. Murmansk, that's a well-known submarine base for the old Soviet Navy and now the Russian Navy. It's a submarine base. Here's Norway. Here's Sweden. This is Finland. So Norway comes over the top. So right about here, Norway, Finland, and Russia meet, have shared borders. So this is Murmansk, the Kara Sea. Novaya Zemlya, that is literally means new earth in Russian. So that's the new earth island there. So that's the Barents Sea. Here's Svalbard, which is part of Norway. Franz Josef Land is part of Russia. There's a little pile of islands here. There are people who actually go here for extended periods of time to conduct research. And yeah, it can be a bit isolated there as well. You can see a bit of Greenland there. So this kind of sets up to what we're looking at. I'll be having more to say as we proceed with this sharing of this report. So basically, this region, as you can see, here's the Arctic Ocean. So this can be considered the southernmost, a very southerly reach of the Arctic Ocean. And it's basically undergoing some drastic changes. So drastic that basically in how it has warmed, that it at this point might actually be considered more part of the Atlantic Ocean than the Arctic Ocean. So all the Arctic has been heating up in recent decades, but it is nowhere as dramatic as we've seen in the Barents Sea, right? You know, northeast of, well, let's say Finland. Well, Finland, Russia, Norway, whatever, but you see where it is. Okay. Temperature are climbing faster than anywhere else in the Arctic Ocean. This is interesting, it's being concentrated in this one locale. Not only in the atmosphere, but through the water column. So this is obviously has something to do with the physics, the current flow regime, the mixing regime, and so forth. The northern Barents is becoming saltier as it warms because there's little seasonal melt of sea ice to dilute the water. Typically, what happens in the Arctic, you get, the sea does freeze, but in doing so, you have brine rejection. So the water that remains liquid has a higher salinity, but you have the ice on top. So you have brine rejection. There's no salt in the sea ice. You couldn't melt that and drink it. Okay. So you create, a saltier, make it denser, and it's cold, so there might still be some vertical sinking. But as that sea ice then melts later on, we have that dilution, and thereby we decrease the density of the upper layers. Well, the Barents Sea is basically, it's not even freezing. It's just remaining saltier. And the Atlantic Ocean, and especially the Gulf Stream, is very warm, very salty water. And the Atlantic is saltier than the Pacific by an average of 1 to 2 parts per thousand. So we have some interesting things going on here. So the changes that was seen in the temperature and the salinity has basically moved the Barents to a condition that more resembles the Atlantic Ocean than the Arctic Ocean. Now, this will it could impact dramatically the marine ecosystems. So, when you think about it, I've often said that this planet we live on has the wrong name. It should not be called Earth. It should be called Oceanus, because 70% of the Earth's surface is covered by oceans. And those oceans contain 97% of the planet's water. So, we have, you probably have heard back in the day, the 7 seas and what have you. But, we basically have the Arctic, Atlantic, Pacific, Indian, and Southern Oceans. Of course, they're all continuous. So, sea, by the way, while maybe interchanged with ocean, sea technically refers to bodies of salt water that are partially or partly enclosed by land, if we want to be strictly technical. So what defines where one ocean ends and another begins? Basically geographical features on the ocean floor and physical properties such as temperature. And as I said, I just mentioned that all these oceans are, are interconnected. You can go traveling, and so if you want to say that the Earth has just one big global ocean, you're not wrong. Of all the ocean basins, the Arctic Ocean is the smallest, covering an area about 5.4 million square miles. which is about 1.5 times the size of the lower 48th of the US. Now, I want to quickly scoot back up this way here. It's not shown here, but in the Arctic Ocean itself, there is a ridge called the Lomonosov Ridge. There's a ridge called Lomonosov that separates into two deep basins. And after a while, these basins are pretty much separated from each other. There's no real communication between the two. But the surface waters, yes, there is communication. Typically, the way the flow goes, water comes in from the Pacific side through the Bering Strait. You have some surface flows I'll show you in a bit, and it comes out through the Fram Strait down this way, generally speaking. So you have the Lomonosov Ridge this way, separating the two deep basins on the Arctic Ocean floor. So basically what they're now saying is that the Arctic Ocean could lose a little bit of what's considered Arctic Ocean and have the Barents Sea be more part of the Atlantic due to the changing physical characteristics of it. So as you can see, and they're actually calling this the Atlantification of the Arctic. Basically, the Atlantic is warmer waters and it meets the colder waters of the Arctic. In the northern Barents Sea, it is ice covered, it is cold, it is quite snotty and harsh. The southern region over here is fed by the warm Atlantic waters carried by the Gulf Stream. That way you get cold and warm water mixing, you get great productivity, you have a wonderful ecosystem, rich in ecosystem and lucrative fisheries. So what's going on? Heated water from the Atlantic flows into the Arctic as a layer that travels deep beneath layers of cold water. Remember, the density of seawater is determined not just by temperature, but by salt content. So it always comes down to which is more dense, cold, not as saline water, or warm, very salty water. Well, in this case here, what I just say to you, the heated water from the Atlantic flows into the Arctic as a layer that travels deep beneath layers of cold water. That means the Atlantic water is more dense, so it's flowing in underneath. In the interior Arctic, like in here, a perennial ice cover, this light blue thing here, and a cold, dense atmosphere keep the upper ocean layers cold enough that the warmer water can't mix with them too much. But the Barents is warming, and the Barents is losing its icy cover, especially in the northern region. Seasonal sea ice, which maintains the area's frigid environment, does provide habitat for marine mammals, birds, microorganisms, is disappearing. Since 2000, this Arctic zone has warmed by 1.5 degrees Celsius, which is about 2.7 Fahrenheit. So this is a quote-unquote hotspot of global warming. It's significantly reducing the amount of seasonal ice. As the ice vanished, warmer Atlantic waters now mixed upward. So now it's reaching upward through the water column vertically, reaching the surface. Reduced surface ice means less fresh water from seasonal melt to dilute the warming salt water. By the mid-2000s, a noted shift occurred in the water column, where it was once highly stratified with distinct upper zones of cold water. Warm conditions prevailed throughout the water column. And now Arctic water at sub-zero temperatures in the northern Barents is diminishing rapidly, is now almost entirely gone. This is huge. So this Atlantification is happening and will be probably completed sooner than expected. So unless the freshwater input should recover, the entire region could soon have a warm and well-mixed water column structure and be part of the Atlantic domain. scientists write in their study. This represents a historically rare moment, using their words, in which a large body of water could undergo an unprecedented transformation from Arctic to Atlantic type, the researchers concluded. This article was published in the journal Nature Climate Change, June 25th edition. We see something similar happening over in the Bering Sea. Diatoms are being replaced by coccolithophorids. Diatoms are cold water phytoplankton. Coccolithophorids are warm water phytoplankton. We're seeing a regime here. Now, the Bering Sea, however, the average depth is only about 50 meters. So it's extremely shallow. That's why during the ice ages, when sea levels drop, this is a land bridge. This is Beringia. It's completely shut off. And then you have people walking across, animals migrating across, and so on. That's a whole nother topic of changing the ocean current flows. So I wanted to show you this here. Okay, if you look at the scale here, the darker the blue is, the deeper is the bathymetry, to the ocean floor. So obviously this is down about 4 kilometers, so on here, pretty shallow here, between 1 and 2 kilometers. Here's the Greenland Sea, right there's Greenland. Here's Svalbard, so the Barents is right over here. This is Franz Josef. Here's the Norwegian Sea. Icelandic Sea is down this way a wee bit. This is Fram Strait. This is Fram Strait. Water, after it flows on the surface of the Arctic Ocean, comes down this way. So this is very generalized. This is the Gulf Stream, and when it gets up, here's the Jin Sea, right? Here's the Barents. Okay. Franz Josef is Svalbard. Okay. Fram Strait is right here. So we have the Gulf Stream becoming the North Atlantic. This is where it terminates. This is where the warm waters are meeting the cold waters here. This is where all the interesting things are taking place. The Labrador Current, I'll get to that in a moment. But this kind of shows you the general flow pattern of the Gulf Stream, bringing warm water from the subtropical regions to the subpolar regions. And as it gives off its heat, it sinks. The Atlantic meridional overturn circulation begins a return flow. As it sinks, it finds its own buoyancy, i.e., where its density matches surrounding waters. That's about 1,000 meters down. And it flows back down this way. I've done stories, I've done segments on the ocean currents and so on. So please go check those out. All my videos ever made are still up here, and I'm leaving them up here. If they disappear, it ain't my doing. But all the videos I've ever made are on my channel. Go check them out, please. Okay. So this shows major North Atlantic currents. Here's the North Atlantic current with a drift. So this is where the Gulf Stream is moving up. Now, I mentioned in this video about when you have the warm and cold waters meeting and mixing, you have very lucrative fisheries and rich ecosystems. Okay, East Greenland Current, as you can see, it goes around the southern tip of Greenland into Baffin Bay, makes this flow here. You have the Baffin Island Current, and then it's the same current. They're just naming it by where it's found. It's sort of like you have the brachial artery, and then it becomes the ulnar. It's the same blood vessel, but it's just they're naming it where it's found, next to which bone. Well, this is the same current. It's just being named by where it's found, next to what mass of land. So here at Baffin Bay, this Baffin Island Current now becomes the Labrador Current because here's Labrador. This is Hudson Bay here. Here's Newfoundland. Okay. This right here, okay, where I'm circling the cursor, that's the Grand Banks, which was historically an extremely rich fishing ground. Haddock, pollock, you name it. There was a whole bunch of fish here, and they've been overfished. But this is the Grand Banks. Georges Bank off often further down off New England, it's further south. But kind of running out here. Here's the Gaspé Peninsula. This is the mouth. This is the Gulf of St. Lawrence. In fact, yeah, that looks like Cape Breton Island right there. So this would be the St. Lawrence River. This is showing you surface currents here with a Labrador current. And the Labrador current, as you can imagine, this, starting with the East Greenland current and so on, you get ice coming off here, you get icebergs. The Labrador current is the current that brought the iceberg that the Titanic kind of had a little run-in with. Iceberg 1, Titanic 0. So this is showing in more general terms here, the Labrador current. It continues flowing this way. This is, I think it's about here, it ran into the Titanic. And here's the Grand Banks, right, meeting up with the Gulf Stream, right? Big mixing here, lots of nutrients brought up here, along with a shallow plateau, relatively speaking, and you get wonderful productivity and so forth. So back up to the Fram Strait there. Why is it called the Fram Strait? It's named after a Norwegian vessel called the Fram. Back in the 1880s, Fridtjof Nansen wanted to study current flow patterns in the Arctic Ocean. He was Norwegian. He didn't have far to go. What they did was they actually allowed the Fram to get frozen into the sea ice. And for 2 years, they drifted through the Arctic Ocean, taking careful measurements of where they were going. And it was the first study to map out surface current flows in the Arctic Ocean. I forget where they started, but when they finally did, after a couple of years, finally come out of the Arctic Ocean, they came out through, you guessed it, this section here, and hence the name the Fram Strait. But yeah, he was in a lot of ways kind of the first oceanographer. He was studying what was going on here. Fram was his vessel, and to this day, we often hear of Nansen bottles. Nansen bottles is a sampling device that we use to collect water samples at depth. You lower it to the desired depth, you send what we call a messenger down, which is basically a weight. The weight hits trips a mechanism that encloses the Nansen bottle. Basically, the bottle is really a tube, and you have both ends are open, so it can go through the water column. And when the messenger trips, there's this, two things. Basically, think of like the plunger from the plumber's helper when you want to unclog a toilet or something. That's basically the idea. And it closes both ends, trapping a sample of water at the desired depth. You can bring it up. You can look for phytoplankton. You can measure temperature. You can measure various chemical species, oxygen levels, and so on. You can just get a whole bunch of information from it. And so we name it the Nansen bottle in deference to Mr. Nansen. And the Fram is his vessel. So anyway, this is very profound, very interesting, very kind of startling to see that this whole region is changing. So the Barents are now becoming more part of the Atlantic as opposed to the Arctic. So I hope you found this interesting, and thank you for your time, and we'll talk soon. Hello folks, this is Jim asking for your help. I want to grow this channel significantly. I want to increase the number of people who subscribe to my channel. I want to increase the number of people who are supporting patrons on Patreon for this channel. Patreon.com/Science Talk with Jim Massa. I do not receive funding of any sort from anyone. So the information I share with you is the information as found published in the peer-reviewed journals. No propaganda, no BS, just the science And of course, I give you my interpretations and analyses based on my experience as a scientist. So please tell others of the work I do here. Tell others of my channel. Share my videos. Post them on other social media platforms. But we need to disseminate this information to more and more people, to a wider audience. And I need your help in doing that. For those of you who are already patrons and support me on Patreon, thank you. Thank you for your support and continued support. Together we can do this. So you'll find details in the description box below how to support me on Patreon. And thank you. Thank you for your help. Thank you for your continued support. It does mean a lot to me. We can do this.